Hello, good morning, dear students. Today, let's we see this topic that is called the derivation for the belt of the length. So today we are going to see the derivation on how to find the length of a belt. So that the length in this chapter, the belt drive, this stuff finding the length of the belt is very important in term of designing the belt drive. So, dear students, so we um, already discussed about the different type of the belt drive, and the first today case we are going to be discussed that is the open belt drive. In the open belt drive, dear student, you can see this is a diagram of the schematic diagram of an open belt drive. Okay, so in the open build drive, this is the larger pulley which having a radius. We are assumed that R1, and this one is the smallest pulley and which it's having the radius of R2, and X is the distance between these two pulley. Okay, um, this is the X, and L is the assume that this is the total length of this belt. This belt length is the L. So, we can see the belt this in this point E, H, E, this F and H. This point the belt leave the pulley. Okay, so we can say so this G, J, E. This part is the point of contact, or so the contact where the belt touches to the pulley, and here also F, J, or sorry, F, K and H. Okay, so hope you are understood these things. And so what we do to making this calculation easy, the with the center of this be parallel to this EF, a line is drawn and which is a perpendicular to the line O1 E, and so it's this point new which is coming, which is came, that is supposed so that is called point N. We assume that point N. Okay, I think you are getting now. So this angle, this is this, you can see this angle is alpha. We assume that this angle is alpha and this total angle is a pi. Okay, this is a pi, the half of the circle. Here also the same thing is. So this if this is alpha, then this angle will be how much, you can say. So this one is called 90 minus alpha. If it is a 90 minus alpha, this is already here is a 90, so this will automatically become the alpha. So you are getting this point. I hope you are not having a problem to conceptualize these things. So let's move ahead, and you remember this diagram. This is a very important. So we will go one by one, and at the last we will add the all the value, then we will get the length of the belt. Okay, so let's see the length of the belt L. So we have assumed that L is the length of the belt. So we can say the arc, this arc, this whole arc, if you say this one whole one, or this we can say arc J E plus E F plus R F K. If we do the two times of this, so it's you get the whole length of the belt. Okay, so we did the same. You can say the two times of R J E plus E F plus R F K. Then now we need to be calculate uh, this part. So we are know that what is the length of this. We can calculate this. It is a very simple. 90 plus alpha into r, we will be get J. Here also we can calculate Fk. How much? This is the here total is 90 and minus alpha. 90 minus alpha into the R2. Okay. Here is the R1 is the radius of this and R2 the radius of this. So like this, and this mean you to be calculated only EF. So EF, how can we calculate the EF? So you can see that this construction work we have done. So once if you calculate, if you are able to calculate this length, so which is equal to this, so which is we can say, we can able to say. So actually let's find out करते हैं. So how can we do that? So we have this angle, we have this length, and we have this also. So move ahead. It's very simple. So using this concept, so sine alpha is equal to, you can see sine alpha O M OM upon O1 O2, and OM you can write as how this is this part. So this part can be also, we can write as the whole, this whole O1E minus of this EM, minus of EM. So it's become, so you can see there, this length is called, total is the R1, and if you minus this is equal to the R2. So this become R1 minus R2 upon X. So let's see that. So if the sine alpha is very small, so we can write sine is equal to alpha R1 minus R2 upon X. So arc ZE, you can see arc ZE is equal to R1 pi by 2 plus alpha, and Fk I already explained you. So this one is this pi minus alpha into R2. So EF is equal to MO2. That is, how can calculate that? You need to this one. So you can say under root of, under root of, so this minus this. So you can see the O1 O2 ka square minus O1 M ka square. So we can calculate this, and so now we take the x as a common. So it's become under root of 1 minus R1 minus R2 whole square. So by using the binomial theorem, and you know the much is much aware about this theorem. So by using this binomial theorem, we can write this equation as x minus R1 minus R2 upon 2x. Okay, so all the value what we have obtained, the L is equal to 2 times of R1 pi by 2 alpha plus x minus R1 minus R2 upon 2x, what we have received, obtained right now, and this, and by the simplify all that, so we can say R pi R1 plus R2 plus 2 alpha R1 minus R2 2 and this, and put the value of alpha here. So now this relation become, so this is pi R1 plus R2 plus 2 pi, sorry, 2 R1 minus R2 का whole square upon x plus 2x minus R1 minus R2 का whole square upon x. Then you simplify this. You can see the student, this one, 2 is there, 1 is there. So it's just subtracting over here. So now it's become like this. Okay, so we can write into that pi R1 plus R2 2x plus R1 minus R2 का whole square upon x in term of Coulomb radii. Okay, if you want to be right in term of diameter, so what do you do? That simple, you just divide by 2 and multiply by 2. So now this relation becomes this. So now, see the length of the cross belt drive. So similarly, we can solve this one also. One only difference is that here you can see, dear student, in cross belt drive, belt cross like this. So here the angle of contact is increased. This angle of contact has been increased, and in this part also it is increase. So here point H F E and G, where the belt leave the pulley. So now the whole arrangement right now like this. So we all know that. Similarly, that how can calculate that? J is equal to R J E plus E F plus R F K and H, and we can also 2 times of R, this J, this R J E plus this one and this R. Hope you are understood. We are the same. Then we calculate the value of alpha. Okay, sine alpha similar. Then what difference is that you have to be extend this and you have to be extend this. So now in the last time it's in this OMM, it was the R1 minus R2. This time it's become R1 plus R2. That's difference only. And one difference will come here. Here alpha again it will come in the plus, and and last time it will be the minus. What pi minus now. Okay, so let's see that. So alpha sine alpha is equal to O1 m O2 O1 and O2 O1 and O2, then so now it's become R1 plus R2 1 and Rx, and already we know that alpha is very small, so we can alpha is equal to R1 plus R2x, and Rj is equal to pi sorry, R1 pi by 2 plus alpha, then Fk is equal to R2 pi by 2 plus alpha, and then Ef we can calculate that. Similarly, what we had did in this triangle, you can see that this big one triangle. Okay, so it's become O1 minus O2 ka O1 minus O2 ka square minus O1 m ka square. Here x and m equals to, then here again this, and we use the binomial theorem again here. So this relation become x minus R1 plus R2 by square upon 2, and put all the value on that. So simply you can see, my dear student, put all the value and simplify, then put the value of alpha. So what we are going to, what we have got the final relation here in this, only the all thing is the positive term. So pi R1 plus R2 plus 2x plus R1 plus R2 ka square upon x. Okay, so here the whole term is the positive, and the last one this was in the minus. So if this is in term of radii of the pulley, we want to be right in term of diameter, so we can write like this. Just in the numerator denominator multiply with. So one more thing you can see, the power transmitted by the belt. So power transmitted by belt is very simple. You can see that belt. So if the it is the driving pulley. If the driving pulley is rotating the clockwise, so this side become tight side and this become the slack side. And R1 R2 already know the radii of the driver and the follower pulley, and V is the velocity of the belt. So effective driving force is called T1 minus T2. The work done per second will be T1 minus T2 into V. And work done, you all know that the work done per second is called power. So P is equal to T1 minus T1 T2 into V is called it is called the power transmission. So hope you are understood. Thank you so much for being here.